All right, good evening. So this is the second part of the videos I usually run. I just pretty much take you through a walkthrough of the homework. If you're in my class, feel free to follow along to do this. If this drives you nuts and you'd rather just work on it yourself, then by all means do that. You're not required to watch these videos. So let me go ahead and share my screen with you so you can see what I'm doing. Let's go ahead and share. All right, so here we go. One of the things, and I will put this in one of the links, is to download a virtual calculator. Uh, if you have a calculator, if you have TI-83, 84, the commands are virtually the same. TI-83 will do you just fine. So that's one of the things you're going to be allowed to have for your quizzes. I do not see a calculator on Alex, so I don't think you're going to be able to be doing any of this with an Alex calculator. So that's where we are. So this is find the mean, median, mode for the following data set. So let's just get through this, or let's get to this. So what we're going to do is we're going to go ahead and hit stat button. And I'm just going to hit enter to edit. And what I want to do is edit a list. Okay. You notice we have L1, L2, L3, all this stuff in there. Make sure your little cursor you're highlighting is under the L1 bracket there. You could be under any of the other L's, but make sure it's under the L's. If you accidentally delete an L or a list, there is a way to get it back, but I don't know what it is. So best of luck. Okay. So I'm just going to go ahead and take these things in here. So my 10 key is still pretty good. We're not don't say we have to clear everything. Okay. We are doing that. Okay, caps lock. So I'm just going to go ahead and say, well, we have 75. Okay. Oops, I wanted 75. Oh, my QQ is pretty good. There 75. Okay, there we go. So stat, edit. We're going to edit our list. We want 75, enter, 98, 63, 89, 75, and 31. Okay. When I'm usually doing this, if I want to do this by hand, what I will do, when I go ahead and list them, okay, one of the ways to do this, okay, it's sorting. The fastest way to sort this, I'm so sorry, 21st century, we still make us do this. So what I'm going to do is I'm just going to say, okay, I've got 75, I've got a 98, I've got a 63, I've got an 89, I've got another 75, and I've got a 31. So I'm going to put these in order because we're going to need that for our median. Okay, it's 31, 63, 75, 75, 89, and 98. Okay, so 1, 2, 3, 4, 5 pieces of data. That sounds good. So what we have to do is we have to find the mean, median, and mode. So what we're going to do to find the median, okay, is we're going to find our middle value. There's 6 values here, right? So we have 1, 2, 3, 4, 5, 6. So we have 6 over 2. That's going to be the third. So what we have to do is average the third and fourth position. Okay, don't tell me it's 3.5. What I want is the 1, 2, 3. This is the third position. This is the fourth position. We're going to average 75 plus 75 divided by 2. I hope this isn't a surprise to anybody that we get 75. We also end up noticing that there are 2 75s. So that's also going to be our mode. Okay, so that's also our mode. Okay. The reason I do this is, yes, can we do this with a calculator? Absolutely. But there's going to be times later in the homework where there's a lot of numbers and I don't want to type them all into the calculator. Okay, my 10 key is pretty fast because I used to work for a data entry place. But unless you practice or, unless you've maybe taken typing in high school, they don't do that anymore. You may not have a lot of talent at typing in 10 key very quickly. So we have stat. What we're going to do is we're going to go to calc, okay? And you're going to hit one variable statistics. You're almost always going to hit one variable statistics. And when we get to chapter 4, we want two variable statistics. It's almost one variable stats. There's other options that we'll worry about. And we're going to hit enter. It's going to say, great, you've picked one variable stats. What it wants to know is what list do you want to do one variable stats on? So we're going to say second function L1. Okay, that gives us the little yellow L1 here. You know, if you just press enter, it automatically assumes that it's list 1. And we'll press enter. And look at that. They gave us X bar. They gave us, we have 6 items. Okay, some of this will come up a little bit later. We have median, which is 75. And I think that's pretty much all they're going to tell us. Okay, they do tell us a lot of descriptive statistics, but for the most part, these are the ones that come out of calculator for us. Okay, so when I want to go find the mean is 71. How many decimal places do they want to talk to us about? They wanted to pick round out one decimal place. So in this case, they want mean. This is 71.83. So we're just going to say 71.8. So we're just going to type in 71.8. Okay, find the median. What did they say that was going to look like? Okay, I'm just using the down arrow to go through. We knew it was 75. We also did this by hand just to make sure. And then there is at least one mode that was also 75. Okay, and then we'll go ahead and say check and then cross fingers, and it looks like we're okay. Okay, so that's our first problem. Okay, we'll say continue. All right. So use the properties to find the mean, median, and mode. Find the mean and the median to determine which is the correct mean and which is the correct median for each of the histograms. Are they asking us to go through and figure this out by hand and be very specific about it? No, they are not. They're saying, well, how would you estimate this thing? Well, we would say, hey, this is going to be a left-sided, the left-skewed kind of distribution, right? This left-skewed histogram. So the median is 50% of the data should be on one side, 50% of the data should be on the other side. So 50% over here, 50% over there. This looks pretty high. So I'm going to say that the median is probably going to be somewhere between 6 and 7. Okay. So median 6.6. I like this option right here. We'll put this in the maybe pile. Okay. And then the mean. Great. And the mean is going to be, well, if I was going to balance this thing on my finger, if I was going to put my finger under this histogram to see if I could balance it, okay, I would say maybe in here, okay, and this is like, well, how did you do that? Like I guessed, okay, and that's pretty much what you're doing. So I'm saying my median is like maybe 6.6, okay, so if I plug it in here, maybe half of the data is over there, half of the data is before that. Okay, and again, it's just very visual, sort of a guess kind of an idea here. So I want 6.6, so that sounds look good. Like, but if I had said this one, sure, maybe. But I like the mean. I like the mean being 5.8-ish. If I was going to put my finger like at 5.8, I think I would balance this thing on my finger. Kinda. If I did 6.3, I think it would tilt. I don't think that would quite do it. I don't like 6.3. I like 5.8 and 6.6 a little bit more. Mean 5.1, median 4.6. Oh, I don't like that at all. Median back all the way down here. Like, I don't think that's going to do it. Mean is 2.1. Median is 3. I don't think that's going to be it either. So I think I'm going to pick this one as my best bet. I'm going to cross my fingers and hope for the best and see if that happens. Hey, look at that. It takes a little bit of practice to do this. It takes a little bit of physical intuition to do it. Fortunately, there is an actual way of calculating this out to do it, but you really don't want to do that. Okay. We have relative frequencies, so this is percentages, so we could figure out something a little bit better. Let's not do that and let's not make it a very difficult. Okay, swimming. I love swimming. Okay, in the recent summer games, Michael Phelps won 5 gold medals in swimming. The following are the events he won. Well, along with his margin of victory. This is our values for margin of victory. Let's see here. So recent summer game. He won 5 gold medals. 1, 2, 3, 4, 5. So each one of these is its own independent thing. Okay. So he 5 gold medals. These are the events he won, along with the margin of victories in seconds. So I think each of these is a single observation. Notice they have 4 times 100 miles freestyle here, 100 meters, not miles. 4 times 100 meter freestyle. I don't think that they're counting this as 4 because he said he won 5 gold medals. So I don't think this is 12, 13, 14. I don't think that's what they're doing here. I think they're saying this is 1, 2, 3, 4, 5. So we're going to go ahead and we'll go back to stat. We are going to clear the list, okay? And then just like the other one where it says, well, you've cleared a list, which list would you like to clear? I'd like to clear second function L1, clear list 1, and it's done. Okay. So we'll go back to stat. We're going to edit a list. Hey, notice that they're all gone. And we'll just type these in. So this is 0.09, enter. Okay, 1.92. Okay. 0.63. You don't need the leading 0. 2.44. Okay, 1.23. The calculator will know. So those are our 1, 2, 3, 4, 5 medals that we have. So we're going to go ahead. We're going to go back to stat. We're going to say calc. So we're going to use the arrow key to go over calc. 1 variable statistics. Which column would you like to do 1 variable statistics on? Second function L1. Enter. And there we go with our values there. So the average, the mean margin of victory, this was 1.26, how many decimal places? The 3 decimal places, 1.262. So 1.26262. Okay, 1.262 seconds. So we'll go with that one. Oh, and then that's all I wanted for that check. Okay, that's nice. What was the median margin of victory? So in this case, we could, again, there's only 5 of them, so we could just kind of go through and order them. Okay, we might want to do that just for the sake of doing it. So let's go ahead and have a look. Okay, the calculator did tell us yes, but since there's only 4 things here, there's only 5 things here, we'll just go ahead and say, well, this is 0.09. This was 192. This is 1.92. This was 0.63. This was 2.44. And this was 1.23. Okay. So if I was going to put these in order, which is what we have to do to find a median, okay. 1, 2, 3, 4, 5. So we have 0.09, 0.63, 1.23, 1.92, and 2.44. Yeah, I've had a number of nursing students over the last couple of years, and they were very upset that I didn't put leading zeros in. So I'm trying to be good about putting my leading zeros in to model that for everybody who needs to do it. Some students will take special care for this. Okay, so we want the median one. There's 1, 2, 3, 4, 5. So 5 plus 1 divided by 2. So 5 plus 1 is 6. 6 over 2 is 3. So we want the thing in the 1, 2, 3rd position. That's the 1.23. That's how we're going to get our median in this case. Okay, so we want 1.23. So margin of victory median, 1.23 seconds. 1, 2, 3. Okay, and then cross our fingers and hopefully that'll work. All right, great. And then assume that the margin of victory for the 100 was incorrectly entered as 19.2. With the mean income or median, what would happen to that, to what's going on here? So if we change this, instead of a 1.92, we changed it to a 19.2, that's going to yank the mean up by quite a bit. Okay, like if you won a race, you know, notice he won the race by 1.92 seconds. All of a sudden he's winning by 19.2 seconds. I mean, did the other swimmer die of old age? What happened here? So it's going to yank that average way, way, way up. Okay. The median isn't going to change. Okay. So the median would increase. So the mean increases, but the median is going to change. I could change this to 19.2. It's just going to move where this is, but this 3rd position is going to remain 1.23. So the median is not going to change. Okay. since it is not a resistant measure. Okay, that means that if you have an unusual or this weird observation, that it's not going to change the median. Okay, so you have to be careful about that. That's sometimes why we use medians, because if you have very wide degrees of data, or wide measures of data, you're better off using the median, because these large numbers are not going to change what the middle actually is. Okay, normally, this is also be a time when I start talking to you about outliers. So I'll do that a little bit, and then we'll go ahead and continue this a little bit. So just to say a little bit about outliers, okay. I don't like to use the word outlier this early in the course, but they do. Because a lot of fancy techniques and statistics rely on you having no outliers. And most people, because they want to use the fancy technique, they're just going to say, well, we'll just set those aside and come back to it. And if you had watched the news earlier this summer, in 2022, you may have noticed the governor of, I think, Mississippi was talking about its maternal mortality rate. And he says, we'll just set aside all the Black people, and then it looks pretty good. Like, you can't do that. You have to have if you're going to set aside outliers, you need a reason to set those aside. Okay, when I make pancakes, okay, most of my examples are free. When I make pancakes, the first couple of pancakes come out to be a disaster, right? The ones after the pan heats up, I'm pretty consistent, and almost the rest of the pancakes after the first one or the first two look absolutely beautiful. Okay, so if you said, well, the first one's an outlier, like, there's a reason. The pan was still heating up. Okay, so I have a reason to set those aside because they're different. Okay, so if you're working like one of them, like there was an industrial process I was studying once, and the machine took a while to heat up. So the first, if they turned the machine on and started going, the first two things that they would make would be kind of a mess. If you turn the machine on, went to go brew your coffee, went, to go grab a bagel or whatever, and then you started working, then it was just fine. But until you let the machine warm up, then the first couple were always a problem. So you set those aside because those were outliers. The machine didn't. A lot of times, if you do surveys, if you're in campus, if you're going to school in campus, if you're doing surveys, and it's like, hey, would you record people's ages and ask them a survey question? Like, hey, do you think the cafeteria hours should be better? You've got your ages, 18, 19, 19, 20. I think our average age for CNM is like 36. But if you're standing there and you did 81, okay, then we'll come back and we'll ask you, okay, did you really interview an 81-year-old person in the student union building at this time? Or do you think maybe you got the numbers swapped? So if you really did end up interviewing an 81-year-old person, you'd probably remember that. It'd stick out. We got to keep this information because that's legitimate data. You ask somebody who's 81, their opinion counts too. If you say, oh, you know what, I don't remember anybody really over the age of 40 coming to talk to me, then we say, you know what, this is probably an outlier. We could probably either set this aside, we might fix it, go back to 18, but we need to have a reason to set aside outliers, to set aside unusual observations. So just try to remember that. So when they bring this stuff up, you can't just like set aside like entire classifications of people. It's like, we can't just decide like, well, if we just do Black people, then our maternal mortality looks pretty good. No, you're not allowed to do that. If you wanted to set aside all the mothers who had cancer, and there weren't too many of them, you'd say that's a special case. Okay, so that's something you could say. We're going to set that aside because these are all special cases, and there's a reason to set them aside. Okay, you can't just set aside data because it's inconvenient. Okay, you have to have a reason for it. So I'm going to go ahead and stop this here, and I will continue working on some homework. So we'll come back and we'll finish doing some homework. Okay. All right.